Learn how to add a widget extension to an existing app, including reusing service classes, building UIs for different size classes, and scheduling widget updates through a timeline. Hey Code Crew, this is Flo. I've been developing iOS apps since 2016 and I've been working on many different widgets over the past few months, so I'm super excited to teach you about WidgetKit in this series. This is lesson 1, where I will show you examples for great widgets by Apple, the current project setup, and the example app that I have prepared for you. Next, we will add a widget extension and go through everything that Xcode automatically generates for us. Let's get started with some examples of great widgets, so you understand how all of this works, how the ecosystem works, and how they are built up. So there's this great article from the Apple developer website, which is linked in the description, which just gives a brief introduction to WidgetKit. And I just want to show you a few of the examples that they have on their website here. They have the little calendar widget, they have a weather widget, news, music, also for the activity app, and so on. Then there are a bit larger widgets for the iPad with photos and a bigger calendar view. But one thing that unites all of them is that they have at-a-glance information. So you, for example, in the calendar widget, you only have the next 2 events showing. So when you have a glance at the widget, you immediately know what it wants to show you and what information is there. Same for the weather widget, you just have a quick look at it and then you instantly know the temperature and the current weather conditions. There are also some more widgets that I want to show you that I have personally worked on. The first one is a food tracker app, which is based around a medium-sized widget that you can see in the screenshot in the middle here. And the idea is basically that you can track your meals through a widget where you can just tap either on the healthy or on the junk side of the widget. The app will open up and all of your meals will get logged that way. So there's a tiny bit of interactivity here, but I will tell you more about that in just a second. And then there's also another widget that I made for a SwiftUI Jam a few weeks ago, which is an almost fully working calculator widget. So we can watch the video here. It looks just like the calculator app from your iPhone, but then you can tap on the numbers and on the operators. The app will briefly open up, close back down again, and then you will see your calculation and the end result inside of the widget. I think this is very cool. Obviously, this is not what Apple intended widgets to be, but there you can just see what's possible with the technology. So getting back to WidgetKit itself, widgets are built entirely in SwiftUI. So it is not possible to port UI kit, for example, via UI view representables or UI view controller representables. Currently, you can only use SwiftUI to build out the UI side, so what's displayed inside of the widget. As I said, the main idea is to provide at-a-glance information. These are just tiny portions of the screen. The widgets are based on a timeline. So you, the developer, can provide a timeline scheduled with timeline entries that all have an associated date and some data associated as well. So you can, for example, schedule a timeline over the next 5 hours, where at every full hour there is a timeline entry. And then iOS or iPadOS or even macOS, whichever system your widget is running on, will execute that timeline and refresh the widget by itself. So you're not guaranteed to have the widget refresh at exactly the time in your timeline entries that you have specified, but the system handles it, and the system also has some limitations. For example, you cannot refresh your widget a few hundred times per day. There are just certain restrictions there set by iOS, but most users will never notice this, and for most users the widgets will always stay up to date. We will have a look at the timeline entries and so on, partially in this, but mainly in the next lesson. And then one last very important thing when talking about widgets is that you understand that they are static UI. So there are no animations, there are no videos, there is no navigation, and there are also no buttons. The only dynamic thing that a widget can do is link into your main app and pass in some data there. We will have a look at that in the 3rd lesson of this series, but until then you can just assume that a widget is more or less a very static view. Okay, to get us started a bit quicker, I have already prepared a very simple example app. This is a simple to-do list app based on the JSON placeholder API. You might have already seen the JSON placeholder API. If you want to have a more specific look at it, it will be linked down in the description. It is a very generic API with some, as the name suggests, placeholder JSON data for users, for posts and so on, but we are just using the to-dos route, which you will also see in just a second. So the main app only has a single view, which you can see here on the right hand side. If I press play, then all of the to-dos will be loaded. We will have a list here with the to-do title on the left hand side, and then the status, whether it's completed or not, on the right hand side. So some of these to-dos are open, some of them are already completed. And if we tap on a to-do item here, a little sheet will come up telling us the ID of the to-do, then once again the title, and whether it's open or completed. And then you can, of course, dismiss the sheet like always. Okay, so let's briefly go over the content view here so you understand how this all was built, and then we will have a look at our data class, our to-do, and then also our service class. So first of all, as you can already see, we have a navigation title here, so we must also have a navigation view which surrounds everything in our content view here. And then mainly we just have this single list here. The rest of the code is just view modifiers, but we mainly have this single list here iterating over all of the to-dos, which is a state variable here. In the beginning, this is an empty array of to-do, but later on I will show you how this gets filled. And then inside of the list, we just have a simple button for every row. The button action is to set the selected to-do, which is another state variable, to the to-do of this current row. So for example, if I tap on the first one, then that will be the selected to-do, which is used for our sheet here at the bottom. This has the item initializer where you can pass in an optional identifiable item. In our case, our selected to-do state. And if that is not nil, so if there is some to-do selected, then the sheet will show up and show just a simple group box here. I think this is not too important. This is just for demonstration purposes. If we dismiss the sheet again, we have our list again, and then inside of the list button there's just a simple attributed string, which is brand new in iOS 15, where you can use some parts of Markdown to, for example, bold a region of text. So here you can see these double asterisks before and after the completed or open text, which we just bolded. As I said, this is attributed string stuff, not important for this series. I just wanted to include it to make it look a tiny bit nicer, since this is a very plain UI. Okay, let's continue down. So we already have covered the navigation title, it's just my to-dos. And now the interesting part comes. So for our to-do service, I have chosen to use the new Swift concurrency features. If you want to learn more about that, there's also a series about Swift concurrency made by Stuart Lynch. So it will probably also be linked down below. You can go there after this video, or if you have any understanding issues, then you can just go there and have a look at it. But I think it will be pretty straightforward. Basically what we're doing is we're attaching a task to the list. Task is very similar to onAppear. So the code in here gets executed the first time that the view appears, but you can execute asynchronous code in here. So we will have a look at how that works in just a second, but bear in mind, so this task will get executed one time at the beginning, and everything in here is happening asynchronously in a background thread, or can happen in a background thread. It can also happen in the main thread depending on how it is scheduled internally. And all that this task does in this case is call our to-do service.getAllToDos function, which calls the JSON placeholder API, gets back all of the to-do data, and then puts it into our to-dos state variable up here, which will then be used inside of the list. Okay, and then the last modifier here, I already told you about the sheet, so I think this should be pretty clear. Now let's move on into the data folder on the left hand side here. So first of all, we have our struct to-do. It's important that this conforms to two protocols. The first one is decodable, so we can decode it from JSON, which you will see in a second in the to-do service. And the second protocol is identifiable, so we can iterate over it in our SwiftUI list. This just has 4 very simple attributes: the user ID, the ID of the to-do, the title of the to-do, and whether the to-do is completed or not. Let's jump real quick into the JSON placeholder API, and let's go to the endpoint that we're using, which is /todos. And here you can see where this data is coming from. So this is just a JSON file sitting on the server, and there you have all of the same fields that I just showed you in our to-do struct. So you have the user ID, which is an integer, the ID, which is an integer, the title, which is a string, and then completed, which is a Boolean. Okay, and then the last file that I have prepared is the to-do service here. This is just a very simple helper class to fetch all of the to-dos from the JSON placeholder API. Since there is no need to instantiate a new to-do service every time that we use it, I just added a static shared instance here, so we can always just say to-do service.shared instead of instantiating a new to-do service. We have our base URL, which is just the address of jsonplaceholder.typecode.com. And then it gets a bit more interesting with these 3 functions here. The first one is a very generic networking function that you can use in any of your projects really. But the important thing is that it is built using the Swift concurrency features. So let's have a brief look at how that works. So inside of the function, we first construct our URL. So when we call this function, we pass in an endpoint, for example, to-dos, and then the function will generate a URL for us. So in this case, it would be https://jsonplaceholder.typecode.com/ and then here it would be, for example, to-dos. So this will be the endpoint. We constructed here, this can fail, so if in case it fails, we will just throw a URL error of bad URL. Once we have our URL, we can use the URL session.shared.data function, which is similar to data task or data task publisher if you were using Combine previously. This function just creates takes the shared URL session, goes to the URL that you handed over, and then fetches all of the data from that URL. This is an asynchronous task, so you have to await for the results to be coming in, and this can actually also fail or throw an error, and hence we need to try to await the data from this URL. This function actually gives back both data and a URL response. So in your app, you might want to check the URL response for the status code or any info that the server gave back to you. In our case, we don't care about that, so we can just omit the second value of the tuple here, the URL response, by using the underscore, and we will just unpack the tuple into our data variable. And then the last step is pretty straightforward. We just construct a JSON decoder, and then we decode our to-do, in our case, from the data. Now the interesting part here is, and hence the name generic helper function, we have some generics here. So we have a generic type T, which basically means that we could use this fetch function to fetch any type of data. We could also fetch some users or whatever, as long as that struct is decodable, as the generic condition here says. So let's see how that works. I have 2 endpoint functions basically. The first one is to get all to-dos from the JSON placeholder, which once again is asynchronous and can throw errors, but this one will return an array of type to-do. And this will basically just call our fetch function up here from the to-dos endpoint. So basically just the one that I showed you in the browser a minute ago. As you've already seen, the fetch function is asynchronous, it can throw, so we need to try to await the result of the function. Since we are using generics here, we need to explicitly specify the type that we want to get back. So in this case, if we want to get all to-dos, we want an array of type to-do, and then we just return the result of the fetch function. And then very similar for the last function, which is called getToDoWithID. We can use this one to get the data for a specific to-do, which we're using for the sheet, for example. this function returns a single to-do instead of an array of to-dos. And it's basically the exact same from before. So we need to specify the type over here since we are dealing with generics. And then the only thing that we're changing is the endpoint. So now we're not querying for all to-dos, we're querying for to-dos / our ID. And if we look at that in the browser, so here we have /to-dos, and now we say /1, for example, this will give us just the first to-do item. Okay, so now that you have seen the sample app that I have already created for you, let's do the last thing for this video, which is adding the widget extension. To do that, it's also very, very simple since Xcode does almost everything for you. You just go to File, New, Target, and then in here you can either scroll through all of the extensions or you can just filter for widget extension, double click it, then give it a name. So in our case, I will call it WidgetKit course widget. Make sure to uncheck include configuration intent. That is something that we're not doing in this series. Configuration intent can basically be used for Siri. It can be used for the user to customize your widget, but this is not important for this series. Once you're done, just hit the finish button. And here you can say activate the scheme if you want to, what this does is basically it changes the theme up here in Xcode. So once you have an extension, you can select when you're running your app which scheme you want to run. So you can then either run your main app in the simulator or just run the widget extension in your simulator. For now, let's just say activate. If you want to change this later on, you can just go up here and select either your main app or your widget extension. Okay, and then on the left hand side here, you can see that a new folder was generated, which is called just what we entered into the text field. If we open that up, there's just 3 files, a basic info.plist file, an asset catalog that you can use to provide assets like images, and then there's the WidgetKit course_widget file. This file contains all of the auto-generated code from Xcode. Let me go over the extension and tell you a few words about each of the different types that got generated. And actually, let's start at the bottom here. So first of all, same as in SwiftUI, which I just closed, there is also a preview available for your widgets. I'm closing this right now so we have a bit more space. By the way, to open and close that canvas, you can press Command, Option, Enter. And then there is something that you're probably already familiar with if you've worked in SwiftUI before, because there's now this @main widget struct. This is actually super similar to the @main app struct in your normal app, where you have a body in which you just present your content view inside of a window group in this case. But it also has the @main attribute, which basically tells the device this is the entry point to the app start here, and then it's the exact same thing for your widget. This @main attribute will just tell the device this is the main starting point for the widget, call this, and then you're good to go. So of course this is not an app, this is a widget, and it also has a body. The body has the generic type of, or the opaque type of widget configuration. There are basically 2 different types of widget configurations. The first one is a static configuration, which we are using, and most widgets actually use a static configuration. And there is also an intent configuration, which you can use if you want to let the user edit the widget directly on the home screen. Not important for this series, but just so you know, there's 2 different types of configurations. And then into the configuration, you just pass basically an identifier of the widget, which is defined up here. By default, this is just the name of your widget extension target. You can change this, of course, especially if you add multiple widgets to your app later on. And then into the configuration, you also pass in a timeline provider. We will have a look at that in just a second. Inside of the configuration, you then have your actual view. Now this has a very long and complicated name. We will change that also in a minute. And into that view, you pass in your timeline entries. If you recall, in the beginning of this lesson, I talked to you about you can schedule a timeline with different timeline entries for set dates, which in turn contain some data that you can pass to your view. And basically these timeline entries here come from your timeline provider and get passed into your view over here. You will see this more concretely in just a second. You can also customize your widget configuration by, for example, giving it a display name, which will then show up in the app library. And you can also give it a description. Okay, let's scroll up a bit here. The next struct that got auto-generated is the actual view. This view gets passed in a timeline entry, which is that piece of data that's scheduled through your timeline. And then this example widget here that gets auto-generated just shows some text of the current date of the entry. So nothing very special here. And then the entry actually doesn't contain any data right now. We will customize this in the next lesson. The only important thing here is that your entry conforms to the timeline entry protocol, which requires the entry to have a date property. And then up here, the most important and most interesting part of widgets is the timeline provider. So all of this over here. The timeline provider is responsible for scheduling your timeline entries for your widget over time for the next couple of hours, for the next day or even weeks, however long you want to schedule it. There are three main functions that you need to implement here. First of all, the placeholder function. This is used when the user is selecting your widget in the widget gallery on their actual device. Then there's the getSnapshot function, which just gets back the current version of the widget with just a simple timeline entry or just a single timeline entry. And then there's the getTimeline function, which you can use to schedule a timeline for your widget, including when it will refresh, how often it will refresh, and which data it will show. The very last thing for this video will be taking all of these different structs and moving them into their own files to make it a bit easier to read and to understand what we're working with. So over here in our widget folder, we will add a new file and call this one provider. And now a very, very crucial detail when you create this file is that it needs to be in the widget target and not in the app target. Now you can hit create. And in here, let's import WidgetKit. And then let's move our provider, our timeline provider, from the generated file into this new file. And let's do the same for the simple entry and the view as well. So create new file, Swift file. Let's call it simple entry. Make sure that the widget extension is checked here. Hit create, import WidgetKit, and then copy over our simple entry, just like this. And then one last time for our view here. So let's hit Command N, new file. Let's call this widget view. Hit create. Here we need to import both WidgetKit and Swift UI. Let's copy over this struct over here and move it into this new file. And then we can also command click on it and say rename, and then rename this long name to just widget view. Let's also remove this space here. Let's copy the name and make sure that it was renamed everywhere. So for example, for some reason Xcode didn't rename it over here. So let's get rid of these old names and replace them with the new shorter name. In this lesson, you learned about what can be done with widgets and how they are internally structured. You saw that a widget is based on a timeline and timeline entries, which get displayed in a plain old Swift UI view.